I'm going to start sharing my screen. And actually, I'm just thinking, I did, over the last, well, since last we met, have several questions about one of the activities. And so is everybody all right if I start by explaining how to do that activity again? Um, I had a lot of questions on activity. Ah, everyone's, oh, here we go. The last activity where you are asked to draw a triangle with the given angles. And so I am going to try to remember. The person who asked me questions had sent me the pictures of their triangles. And so I'm going to just look at this A. And looking at that A, the person who sent me their triangles for triangle A, I remember their longest side was 6.5 centimeters. And beyond that, I have to apologize, I don't remember. And so, here, I'm trying to look up what they sent me. Give me a minute. Their neck sides, their shortest side was 4 centimeters. And their middlest side, for lack of anything else, was 5 centimeters. And you're supposed to compare them to that of your partner. And if I remember correctly, because we were doing these virtually, I didn't assign partners. And so rather I had said that I would be everybody's partner. And so as everybody's partner, I had sent you this sheet that had the lengths that I had for the sides of those activities. And again, it's in the top of the learning module tab. If you didn't get it in an email. And so my longest side, my sides were 1.7, 2.6, and 3. So going back here, my sides were 1.7, 2.6, and 3. Now, to find the ratio of the lengths of sides, we're supposed to compare the sides first as a fraction, and then afterwards, we're to take that fraction and write it as a decimal. So as a fraction, the shortest sides were 4 centimeters and 1.7 centimeters. Doesn't matter which way you put the fraction as long as you're consistent. So I'm going to put their triangle above mine. So the fraction is 4 over 1.7. And then with this one, I'm all right if you use a calculator to change that into a decimal. My decimal there would be 2.35. Then for the middle sides, that fraction would be 5 over 2.6. And that decimal, 5 divided by 2.6, turns out to be 1.92. And then the last one was 6.5 centimeters over 3 centimeters. And when I take that 6.5 and divide it by 3, what I get would round to 2.17. And so they're not exactly equal, but they're close. They're all close to about 2. And what should happen, because remember we had said that if all of the corresponding angles are equal, these two angles are equal, these two angles are equal, these two angles are equal. Those should be similar, and those ratios should be the same. Why would they be off? Because the protractors we're using are not that precise. So you might be off by a little bit measuring an angle, but they should be pretty gosh darn close to accurate. And also when you're using that metric ruler, it depends on, I think it's a function of your eyesight. What I see is 2.6, somebody else might have seen as 2.5 or 2.7. So there is a little bit of error here, but those, because they are supposed to be similar, those ratios should all turn out to be equal or approximately equal. So I know that the person I was working with was having difficulties with that one. Is everybody all right with what you're supposed to do for that one? And the way I had put in my drawing with all of my triangles on it, I expect you to please submit your drawings with all of your triangles. So that was what I definitely wanted to make sure we went over today. Other than that, is there anything else that anybody wants to look at, either from the activities for Chapter 12 or from the homework for Chapter 12?
Could you go over number 16 on page 644? I know we already went over it. I just think like you were going a little too fast for me. So
Okay. And I
thank you.
apologize if I'm ever going too fast. Just yell at me.
Okay.
I get that at home all the time. My husband tells me I talk too fast. And so I won't take it personally if you're just telling me I'm talking too fast. Okay.
Okay.
Speed.
I understood A and B, but C and D is like where it's like a little confusing for me.
Okay. If you're doing the conjecture about the right triangle and about the altitudes of the obtuse triangle, I'm going to cheat for a minute because I vaguely remember doing those constructions with you last class. And so I'm going to stop sharing for a minute. And I am going to try to balance behind here those constructions. And so the first one, I constructed the three altitudes in a acute triangle. So again, I use the construction for a perpendicular from a point off a line. From this point, I swung an arc that intersected the opposite side twice. And then from each point of those points of intersection, I swung an arc. From this point, I swung an arc that crossed the side twice. And from each point of intersection, I swung the same arcs. And when I connected the altitudes all met at a point. We know that all three altitudes meet at the same point. So if I draw from the other vertex to that point, I should get that third altitude. Those should be right angles. And do you notice that the point of intersection is inside the triangle? That one you said you were okay with?
Yeah.
When I did it with a right triangle, with my right triangle, if I look for the altitude from this point, well, because that side, the leg is perpendicular to the opposite side, the leg is perpendicular, it's an altitude. The altitude from this point, because it's perpendicular to the opposite side, the leg is an altitude. So in the right triangle, those two sides are two of your altitudes. So what we need to draw is the altitude from the right angle to the hypotenuse. So from there, I'm going to swing an arc, cross two places. From each of those, I'll swing two other arcs and I'll connect it. And you see in the right triangle, the altitudes intersect on the right angle. Is that one okay? And I'm looking at that messy picture that's in the back. I just realized, because I didn't remember drawing things that close together, I just realized that's the shadow of the problem that's behind it. So let me try to cover up that shadow a little bit. I wrote on both sides of the sheet of paper. I apologize for that. Now, what should happen when you do that? So are you all right with the right triangle?
Yeah, I just didn't know why you only constructed one like arc
Okay.
compared to like B, but now I got that. So thank you.
And with an obtuse triangle, you have to be careful. Give me a second. I'm going to wing it just a little bit. Ah, I need a pen. And what happened was last night, I taught my on-campus class. And so all of my really good pens went to my office with me last night. Okay, so I'm going to try to draw an angle that's obviously obtuse. And so if you look at this triangle that I just drew, is it obvious that this angle up here is open wider than a right angle? I could fit a right angle in it. And if I were to construct the altitude from here, it would go down perpendicular. And you can picture doing the construction. It would go down here. The problem, so I'm going to just wing it a little bit and put that in. The problem with this one is, if I turn my page, if I wanted the altitude from this point, if I wanted something from this point perpendicular to this side, you see if I drop that perpendicular, it wouldn't go inside the triangle, it would be outside the triangle. So to do an altitude in an obtuse triangle, what you have to do is extend the side. And you see how I did that with a highlighter? And now with that extended side, I should be able to drop an altitude down from here. And as I drop that altitude down, you see where it's going to meet the other altitude. It's going to be outside of the triangle, somewhere around here. And likewise for this angle, for the altitude, I'd have to extend the side. And its altitude would also meet at that same point. And so if I have an obtuse triangle, the altitudes are going to meet outside the triangle. Is that enough of an explanation for that one, hon?
I think so.
Okay.
Thank you.
You're welcome. Thank you for asking. Any other questions that anybody's wondering about?
Can you go over question 4 on 626?
Sure. And one thing I feel bad about doing class via Zoom instead of live is the 2 days that we've been going over activities like this and homework like this would have been days where the class period was set aside for you folks to just do the activities and the homework. And rather than me broadcasting to the class, I'd just be walking around the room and helping you one-on-one. And I feel bad that that's one of the things that we've lost when we became blended. Which question number again was it?
4 and 6 when you get a chance.
Okay, Naomi. question 4 asked us to make a segment whose length is equal to the length of segment X plus the length of segment Y. And again, I hope you don't mind. Are you all right if I recycle the constructions that I did last class? So I'm going to stop sharing. And, okay. Last class, we said we drew a segment of length X and we drew a segment of length Y. To get a segment whose length is X plus Y, we started by drawing a much longer ray. And then with our compass, we put the point at A, we swung an arc at B, and we used that same radius here. So from this point to this point should be the same length as X. If I want X plus Y, then I have to add the length of Y. And the way I'm going to add the length of Y is I'm going to put my compass point at this point, swing an arc here, and then from the end of X, swing that length Y, so that these two should be equal both Y. These two should be equal both X. And so this new segment with the two pieces together would have as its length X plus Y. Instead, if I wanted the length to be X minus Y, first I'd copy X. And you know how from the end point up here we swung Y and we swung it out to make it longer, X plus Y. Well, this time from that end point, instead of swinging out, we'll swing in. And so this has a length of X and this has a length of Y. That stubby little piece that's left over would be the difference, X minus Y. Better, hon?
Yes, thank you.
Okay. And then question number 6.
Yes.
Let me share my screen again. Question 6 asks, can a triangle be constructed with sides 2, 3, and 6? Well, what did we say about the measures of two sides of a triangle? Remember,
Has to equal the be bigger than the other side?
it has to be bigger than the other side. And so if I look at these sides where I have 2 inches and 3 inches, 2 plus 3, is that bigger than the other side? 6. Is 5 bigger than 6?
No.
No. So it can't make a triangle. So write an intelligent sentence explaining that idea. Okay?
Thank you.
You're welcome.
Could you go over how to like construct the median of a triangle?
Sure.
Thank you.
In order to construct a median of a triangle, I'm going to, for a minute, look back in the notes. In the notes, somewhere around, I take that back. Give me a minute. I found it. In the notes, we looked at doing construction and we had said to construct from a point off a line. We could, I'm sorry, did you ask for the median or did you ask for the altitude? You asked for,
Median.
I apologize.
That's okay.
For the, you know what? Rather than searching there, we said that in order to find the midpoint of a segment, we had to construct the perpendicular bisector of the segment. And so to do that perpendicular bisector, we had said that we were going to open our compass a little bit more than halfway. From each endpoint, we'd swing an arc above and below. And then with that same radius, from the other side, we'd swing the arc above and below. When we connect the two axes, that gives me the midpoint. And it also turns out that that's perpendicular. But when I'm looking for a median, what a median does is it goes from a vertex to the midpoint. So are you comfortable with this construction to find the midpoint? So then if I'm looking for a median, what we did was we drew this triangle. And for the median from this point to the opposite side, the first thing that I have to do is I have to find the midpoint of this side. So for just a second, I want you to pretend nothing's in the picture except side EF. I want to find the midpoint of side EF. So from E, I'll swing the arc above and below. Then from F, with that same radius, I'll swing the arc above and below. When I connect them, I get the perpendicular bisector. You notice when I connected them, I didn't do a solid line, I did a dotted line. Because the only part of that construction that I want is this midpoint.
How do you know what to make the radius when you like swing the arc?
It can be any radius that you want, just as long as it looks like it's more than half the side. And so I'm going to try to recreate here. It looks like over here, this was my radius. That looks pretty close. And it's just, you just want to make sure that you're open more than halfway across. Otherwise, it can be any radius you want. And then after I find that midpoint, to make it turn the midpoint into a median, we're just going to connect it to the other side. I'm sorry, hello. Let's try that again. That's not a side, that's the vertex. We're going to connect the midpoint to the opposite vertex. I apologize, I misspoke. Any better?
Yeah, thank you.
You're welcome. Anything else that anybody else is wondering about?
626, question 19.
Okay. I'm sorry it takes the digital book so long to turn pages. Oh, 19's at the top of the next page. Okay. This question says that ABCD is a parallelogram. And we want to show, first of all, that triangle ABD is congruent to triangle CDB. Are you folks all right if I pull up a blank sheet of paper and write this out on the blank sheet of paper?
Yeah.
So let's go to one of these untitled pages. What we've got here is a parallelogram. Let me try to label it the same way, A, B, C, D. And BD is drawn. And so we know that ABCD is a parallelogram. BD is a diagonal. And we want to end up saying that triangle ABD is congruent to triangle CDB. Well, the first thing I want to know is, what does it mean if ABCD is a parallelogram? What does it mean if something is a parallelogram? What does that tell you about the sides?
They're parallel.
They're parallel. We can say that AB is parallel to DC and AD is parallel to BC. If these are parallel, well, wouldn't this diagonal be my transversal? And couldn't I say over here, this angle is congruent to this angle? And so if AB is parallel to DC, angle 1 is congruent to angle 2 because they're alternate interior angles. But in the same way, if AD is parallel to BC, isn't this also a transversal? And wouldn't that make this angle congruent to this angle? For the same reason. Does that make sense?
Yes.
So I've got those two angles. Well, I think the question said hint, think angle, side, angle. Well, don't they share this side? Since the triangles share side DB, the triangles are congruent by angle, side, angle, congruent to angle, side, angle. Does that make sense?
Yes.
So now then, next part says, prove that the opposite sides of the parallelogram have the same length. Well, if triangle ABD is congruent to triangle CBD, if these two triangles, I'll use my highlighter, the yellow one and the green one are congruent, wouldn't that mean that since triangle ABD is congruent to triangle CBD, doesn't that mean that AB would have to be congruent to DC and AD would have to be congruent to BC because there's parts of the congruent triangles? If the triangles are congruent, doesn't it mean that all of the other parts are equal in measure?
Yes.
And then lastly, we're asked to prove that the opposite angles are congruent. Well, since triangle ABD is congruent to triangle CBD, wouldn't that tell me that angle A is congruent to angle C?
Yes.
And then because angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, wouldn't that make those other angles congruent?
Yes.
Okay, better?
Yes, thank you.
You're welcome. Was there another one you were wondering about there? Or is there another one that anybody else in the class has a question on? Either activity-wise or homework-wise?
Can you go over number 3 on 626?
Sure. So it says, suppose triangle JKL is congruent to triangle ABC. And this is triangle ABC. Remember, we had said that when you name congruent triangles, the vertices have to compare. So over here, I'm going to look down at C first. Angle L. By naming convention, doesn't angle L have to be congruent to angle C? And so angle L would have to be the same as angle C, 56 degrees. Then if I look at angle J, well, J is the first one in the name. So it's got to be equal to the first one in the other name. So angle J is congruent to angle A, which is 41 degrees. And in the same way, side KL would have to correspond to side BC. And so BC is 4, KL would be 4. And then by the positioning of the letters, side LJ, let's see, L and J correspond to C and A. So side LJ would have to be equal in length to side CA, which is 6. And so the secret in the sauce is to remember that if those two triangles are congruent, I'm written all over it, that J corresponds to A, K corresponds to B, and L corresponds to C. Is it easier than you thought, hon?
Yes, thank you. It made more sense now.
Okay,
I have one more.
sure.
Number 25 on 626, or it might be like 629.
Oh, and I'm scribbling all over it because I always forget to turn my finger into a mouse. Okay, 629 is a couple pages over. 1, 2, and which number was it again?
Number 25.
Number 25 says that Dane has been studying quadrilaterals and wonders whether there's a side-side-side congruence property for four-sided polygons. That is, if I know all four sides, that the shape of the quadrilateral, you have to know it. Is that true? If all four sides of one quadrilateral are equal to all four sides of another quadrilateral, because with triangles it works, side, side, side can go into side, side, side. We did that construction, and we said if all three sides match up, then all of the angles match up too. Well, In order to show something's true, you have to show that it'll always occur. In order to show something's false, you only need one counterexample. And I'm thinking I can come up with a counterexample that shows that this is false. What I would do is I would tell Dane, let's draw a square. And let's have all sides be, do you have a favorite number, Stephanie?
12.
So we'll have all sides be 12. But can't I also draw a rhombus with all sides 12? And they have the same length of sides, but are they the same shape?
No.
No. So with 4 sides, knowing all 4 sides is not enough. I don't know, for example, if all sides are 12, whether I should draw a square or a rhombus. We need to know an angle in a quadrilateral, at least one angle, if not more. Okay,
Yes, thank you.
you're welcome. That's actually why I'm going to go off on a tangent now. That's actually why just having the 4 sides is not enough, because it can change shape. And that's why if you ever look at anything like a structure, like a bridge or a lot of times a fence, there's a diagonal in there. Because once that diagonal's in there, now I've got 2 triangles and the angles have to be the same. And so that triangle keeps that figure braced solidly, as opposed to if I just had the 4 sides, it could eventually move into a rhombus. But once that diagonal's in there, those triangles cannot change angles anymore once I've got the 3 sides set. So if you ever look at a structure, like if you look at a bridge when you're going over it or something like that, you'll find that most of the bracing divides it into triangles and not squares or quadrilaterals. You need those triangles because they're side, side, side works. Once the 3 sides are set, the angles cannot change. So, anything else anybody's wondering about? If not, initially I had uploaded the outline for chapter 13 notes, but obviously I don't think we have enough time left to start chapter 13. So I'm going to go back up here to this beginning of chapter 12 notes. Your chapter 12 homework is due today, as are the activities. Please try to get them into that Dropbox today. Chapter 12 test is due on Monday the 5th. I made it due on Monday the 5th instead of Sunday the 4th, because I know that Sunday the 4th is a holiday. And so I don't want to impinge on anybody's holiday, so that test won't be due until the end of the day Monday. And also on Monday the 4th, please remember to bring some M&Ms to class with you. You need a tablespoon of M&Ms. So one of those tiny little packets like what you get for Halloween would be enough, or a single serve bag would be enough. Or if you really like M&Ms, go out and buy that 2-pound bag, but we're only using a tablespoon of it. What I ask though is that your M&Ms be regular M&Ms. I don't want any fancy colors for fancy holidays. They have to be just your plain old regular M&Ms, because we want to sort them by color. So don't be buying the pretty pastel Easter M&Ms. Or if you got a sack of pretty pastel Easter M&Ms in your Easter basket, those won't work. I need those traditional red, blue, green, brown, yellow, and orange M&Ms. Okay. Any other questions on anything? If not, I know it's a little early, but I can stick around if you guys want to just continue working on things on your own and ask questions. Or if you want, we can call it a day. I just want to double check and make sure. I don't remember letting anybody in class late. I think we got everybody on attendance the first time. Is there anybody that I missed on attendance? Oh, geez. And you look at that. What a mess. That's ripping over a bag of paper on the desk because the desk is right next to the printer. You don't need to see that. Let me change my video settings. Although I'm sitting and thinking, looking at me isn't much better than looking up at that ripped sheet of paper. Does anybody have questions on anything else?
What if I don't get to the test this weekend because of my wisdom teeth? Because I don't know how I'm gonna do.
It's going to be open until the end of the day, Monday.
Okay.
Okay. If you still have problems Monday, touch base with me, but it's open till midnight Monday because Sunday is a holiday and I don't know, there isn't class on Friday because of, some people it's a religious holiday and likewise Sunday is. And so I don't want to impinge on anybody. If is an important holiday for anybody, I don't want to impinge on anybody's family time. And so that's why it's not due until the end of the day Monday. Okay.
Okay.
Over the weekend, if you do have any questions on anything, please feel free to send me an email. And otherwise, have a great long weekend and we'll see you Monday.
You too.
All right. Happy Easter if you observe it. If you don't observe it, happy spring long weekend here. It's the closest we get to a spring break, right? So have a good one, everybody. Bye-bye.
Have a good one.
Victoria, you okay?
Yeah.
Okay. All right. Well, then we'll see you on Monday. Bye-bye.